Good morning, students. Once again, I welcome you to my video lectures on signals and systems. Now, in Z transforms also, you have two theorems to study. Previously, when you studied Laplace transforms, you had two theorems: initial value theorem, final value theorem. The names remain same. In Z transforms also, we have two theorems: initial value theorem and final value theorem. Now I will state these theorems and I will prove. Before proving these theorems, so first understand what do you mean by initial value. So two theorems being stated: initial value theorem and final value theorem. What do you mean by initial value? Initial value means the initial value of the function. Initial value means x of 0. T equal to 0 or n equal to 0 is what is called as initial value. Final value means the value at infinity, that is at x equal to infinity. This is what is called as final value. This is what is called as initial value. So you can find initial value as well as final value if you have time domain expression of x. If you have time domain expression of x, then if you substitute t equal to 0, you will going to get initial value. If you are going to substitute t equal to infinity, you will going to get final value. But we are not having time domain expressions. Instead, we have z transform. That is, you are given x of z. From x of z, you have to find what is x of 0. From x of z, you have to find what is called as x of infinity using final value theorem. So, from x of z, you have to find initial value as well as final value. Now, first, I will take up initial value theorem. Very simple to prove the initial value theorem rather than final value theorem. So, what is this initial value theorem? Initial value theorem is stated in this manner. Initial value theorem. Now, first you assume that you are given x of n and its unilateral z transform is x of z. Its unilateral z transform is x of z. X of n, x of z. Now, this x of n is causal. That means it is right sided. So, x of n is x of z. So, in the Laplace transform, you had initial value theorem as like this. X of 0 is equal to limit s tending to infinity s x of s. In the Laplace transforms, you had this theorem in this form. X of 0 is equal to limit as s tending to infinity s times x of s. That means you have to multiply x of s with s and you have to take the limit as s tending to infinity. But in z transforms, you can find x of 0. So this x of 0 is also written like this: limit as n tending to 0, limit as n tending to 0, limit as n tending to 0 x of n is equal to limit z tending to infinity x of z. So take x of z, take the limit as z tending to infinity. That will give you its initial value. This is what is called as initial value theorem. Now I will prove this initial value theorem first. Now first, what is x of z? X of z is equal to, we know from the definition of z transform, n equal to minus infinity to plus infinity, x of n z to the power of minus n. Now x of n is a causal signal. That means its left sided values are all zeros. That is for n equal to minus 1, minus 2, minus 3, etc. zeros. Therefore, this reduces to summation n equal to 0 to infinity, because it is right sided. X of n z to the power of minus n. Now you write few terms. First take n equal to 0, x of 0, z to the power of 0 plus next 1, take n equal to 1, x of 1, z to the power of minus 1. Next take n equal to 2, x of 2, z to the power of minus 2. So in this way you can write many more terms like this. Now having written few terms, take on both sides limit. Take on both sides limit as z tending to infinity. As z tending to infinity. Limit as z tending to infinity. Now if you take limit as z tending to infinity, before taking z tending to infinity, now I will write x of 0 plus x of 1 by z plus x of 2 by z square, etc. Now take limit as z tending to infinity. As z tending to infinity in these terms, as z is in the denominator, therefore anything divided by infinity is 0. Therefore, if you take the limit, this becomes 0, this becomes 0, every term after this becomes 0. Only term that is left over is x of 0. Therefore, limit z tending to infinity for these terms remains with x of 0. Therefore, what is x of 0? X of 0 is limit z tending to infinity x of z. So, how to find initial value? Take x of z, take limit as z tending to infinity, it will give you initial value. In the next class, I will work out problem on initial value theorem. Thank you.